Thank you, Ashwin, and good evening, ladies and gentlemen. Pleased to be addressing this forum. I hope you can all see the presentation slide. The first one is the M2M, machine-to-machine communications. And specifically, we will be talking about wireless monitoring and control applications within the context of M2M. I'll skip the introduction. So let's first define what we mean by machine-to-machine communication. At the very basic level, it's nothing but devices and systems communicating through wired or wireless networks. It's essentially connecting your machines, getting data, useful data from the machines that you can use either for your business values or for optimizing your asset. And it is also sometimes talked about in the term Internet of Things. It's another latest marketing term as an umbrella for these machine-to-machine communications. But machine-to-machine, or the machines communicating over wired or wireless networks itself, is nothing new. I mean, we have been having SCADA systems since back many decades ago. But what has brought this piece of industry forward in the past few years is some convergence of very important factors in technology. And those include low-power computing, embedded computing, and many types of wireless technologies that are made M2M possible. So these factors, in conjunction with the growth in data processing or the servers that again go back to the amount of computing technology that has come up, has enabled machine-to-machine to be a viable and more pervasive in its implementation. In this presentation, I'll talk about these factors in particular, so we get an understanding of what is happening in this ecosystem. And in the second part, I will show you specific examples of M2M communication setups and how certain problems are being solved in certain examples industries. Good. On the first factor is the low power computing. As many of you probably know, thanks to Moore's law, the MIPS, million instructions per second, that is available per watt has consistently come down over the years. Back in 1970, it was about a watt per MIPS, and today you can approach almost 10 watts per MIPS of computing power, and the small microcontrollers afford a lot of computing that can be done in many of the machines or many of the portable devices that you see. And with this low power computing, it is possible to do a lot of computations in your own machines in many forms, and also afford embedding these computing powers in different areas of your machinery, not just one piece of machinery. And this is a very important piece of the puzzle that has come up that enables M2M. The next piece is the wireless technologies. Now, I'm going to simplify this a little bit. There are obviously many types of wireless technologies available, but I've only picked 4 to compare and contrast in this scenario. And the first comparison I want to make is the types of wireless technologies, namely Zigbee, Bluetooth, Wi-Fi, and cellular technology, and compare them in range versus bandwidth. Okay, I'm sure cellular, everybody is aware of it. It goes to many megabits per second in the latest technologies, and it goes to thousands of meters. That's the easiest thing to understand. The next easiest is the Wi-Fi technology, which we are all familiar with probably in our corporate environments or in your airports, where Wi-Fi is used to connect laptops. And Bluetooth, which is present in many of the cellular or all our handsets, is the next most familiar one. And the fourth one, which some of you may not be familiar with, is the Zigbee. And this is the low power RF technology for short range communication or very small network communication. Okay, you can compare Zigbee to Bluetooth or RFID that you may be aware of in terms of the performance and the usage. Zigbee has a range, depending on how you measure it, anywhere from few meters to hundreds of meters. And it has a bandwidth, theoretical bandwidth of 250 kilobits per second, but achievable bandwidth may be a little less than that. And the Bluetooth has about a little less range than the Zigbee, but it has a higher bandwidth in terms of what you can transfer over it. The 32 kilobytes, less than 32 kilobytes for Zigbee and less than 250 kilobytes for Bluetooth is essentially how much memory it takes to implement the stack or the technology of the Zigbee in a particular microcontroller. And the reason that is important is the lower the memory is, the cheaper it is to implement this particular stack. So obviously Wi-Fi takes about a megabyte to implement, and Bluetooth takes 250 kilobytes, and Zigbee the least. And that means that the Zigbee technology can be used effectively for many small applications where bandwidth of transfer of bandwidth is only less than 250 kilobits per second, and you're operating within hundreds or maybe a few hundred meters of range. So this is the first picture I want you to keep in mind for the types of wireless technologies and what their characteristics. Now remember this picture, and now I'm going to switch to the picture of range versus battery life. The picture changes a little bit, and the most important thing is the range is still the same, but Zigbee scores very high in terms of the battery life. And the reason the battery life is important in our M2M networks is when you want to operate a remote asset without having a power or without having to power it up constantly, these technologies can work off of a battery, and you want to have a very long duration of life cycle for embedding these technologies within the machines. And from that perspective, Zigbee scores very high, and there are a few other technologies like RFID and ANT networks or dust networks that are also very comparable or even sometimes superior to Zigbee network itself. And the next comes Bluetooth. It's a lower, we know maybe the battery life may be like 10 days if it keeps operating. Wi-Fi is even lower in terms of the battery life, but mostly Wi-Fi is today used for powered connection. And cellular, we all know it's about a week or so of battery life. So understanding the wireless technology and their characteristics such as range, power, battery life is important, because when you try to solve the M2M networking problem with your networking solutions for your problems, these factors will come into the picture. Okay, the next important factor in M2M adoption is the pervasive nature of embedded computing. This graph kind of shows how the number of places or number of things that the embedded computing is getting embedded in. It could be in anything from fridge, a washing machine, a laptop, a printer, anything and everything is possible to be embedded with some intelligence. And that goes back to our first slide where we talked about the power and the amount of computing power available for very small power. And that also enables the pervasive nature of embedding intelligence in so many things. The projections are that in about by 2020 or 2025, we are going to see these intelligent devices zoom up to almost 50 billion devices. In the more concrete terms, in terms of industry floors or machines, which are not daily usage devices, this number could be even more. That is where it gets interesting when we have embedded intelligence in your automation systems, in your machineries, in your vehicles, in your wearable devices. These kinds of things have embedded intelligence. Now when you put all these things together, now it drives the necessity to connect these devices together and extract data out of them. And that data is what is essentially what M2M is trying to achieve, extracting of the data by connecting different things. So having understood what is it that is driving the M2M networks today, let's look at the M2M networks network elements. On the one end are the products themselves. The products as shown there could be anything from vehicles, a smart energy meter, a small measuring instrument, a washing machine. Any of those could be is your machine. Okay, and when you're trying to take the data out of these machines and communicate to the other end, you have something called a wireless hardware or a module, because these devices may not inherently come with a wireless connectivity. They need to have some kind of hardware that needs to get augmented to that. That's a wireless hardware module. And next comes the wireless network itself. And the wireless network could be, as we discussed before, the wireless network could be a short-range wireless networks or a long-range wireless network like cellular networks. Any of them could be an opportunity, or any of the choices of the network. And the other end after the network is the application gateway. The application gateway is nothing but an application that processes these data in the format that you want, or analyzes this data. And then comes the internet. You could choose to transfer the data over internet to a remote place where you could be consuming this data or analyzing this data over a web browser or any kind of system at the back end. So essentially, these are the elements in a complete M2M network. Out of these elements, you may or may not use all of them, or at least the back-end systems may or may not be there in some cases. In your case, it may have just a local wireless network and the wireless module connected, and you might be monitoring it just in your factory floor. That is also possible. And please notice, on top of all these things are the IP cellular communication support. You need to worry about security features if that is of critical importance to you. You also need to worry about management application services, because you are going to be managing hundreds and thousands of devices that are scalable, that may have the data that you are interested in. Okay. Now this hopefully gives you an idea of what an M2M network elements are. Whenever you think about solving your problem with an M2M network, all these elements have to be thought through. And as I said, some of them may be useful, some of them may not be useful for you, but nevertheless you have to think about how you're going to pick these elements for your own system. Okay. Now I'm going to take a quick break and check if there are any questions so far before I jump to the example sections of it. I will show you some concrete examples in the next few slides.
Yeah. If you have any questions, we are giving a 2 minutes break for you to type those questions, and we can answer it, and then we would proceed.
Good. Let's continue. Okay. The first application I want to present to you is a remote DG monitoring solution. This is a very relevant solution in the current situation. There have been a lot of interesting applications around this. This is essentially monitoring your DG, diesel generator, from a remote place. This could be mandated because your DG may be installed in a very remote place where you cannot inspect it every day. Or it could be mandated because you want to monitor the parameters of the DG to assess the efficiency of the DG, or if you want to detect a fuel theft, or if you want to audit purposes, you want to measure the DG kilowatt hours, or even to remotely turn on or turn off the DG depending on your requirement. There are quite a bit of things that you could do with a remote DG monitoring solution. In a traditional, many years ago, DG must have been operating and it does have an intelligence, but there was no remote monitoring possibility at that time. But now, with a simple addition of wireless connectivity and a backend system, it is possible to remotely monitor your DG. And I think back to the M2M functional network, and if you compare this, there is on the one end there is the DG, which is the machine that you're trying to monitor, and the next is the remote monitoring device. And this remote monitoring device is actually working on a cellular network, and it transmits the data over the internet. It comes back to a central monitoring server or station. This remote monitoring device would be operating on a SIM card, which operates on a GPRS network. It could also have SMS capability if you want to do diagnostics information. The way to connect this monitoring device would potentially be connected to your DG set through some important signals, for example, DG on and off signal, or it could be connecting to the DG kilowatt hour measurement instrument, or it could be connected to the battery of the DG. In all these cases, it is trying to measure or trying to extract data from the DG, let's say in a periodic 10 minutes, once every 10 minutes or once every 15 minutes, and it transfers it back to the internet, to the server, and to the central monitoring station. Another one is you could also be measuring the fuel level of this particular DG by just putting a fuel sensor in the DG. Okay, so there's a very simple example of augmenting a DG with a remote monitoring device and then transporting the data back to a central station. As I said, it is also possible to control the DG from remotely to turn off the DG, turn on the DG, or do any of the other relays that you may want to control it. In the backend system, this is a picture of how a backend system of a DG monitoring would look like. This is just you open it on a web browser, and you would potentially see the fuel level at that time in the DG, and you can also see the DG status, is it on or off, DG runtime. You could also see the runtime for the entire day, or you could potentially get historical runtime information. Those kinds of things are typically what you would see in this DG. You could also enable this backend system or the monitoring device to send you alerts such as SMS or email alerts to make sure that you get some alert parameters either when a fuel level falls inexplicably and in terms of theft, or battery level falls below a certain point where it needs maintenance. Okay. Oops. Okay. Not sure why this is. I see solar panel monitoring, but I see some of the pictures missing in the slide. But essentially the missing slide is the backend monitoring system as you saw in the DG monitoring. Solar panel monitoring is yet another very interesting application because of machine-to-machine. And what it does is, in your solar panel, you typically have a charge controller or an inverter or an MPPT controller that is installed in the solar site. And you can connect a monitoring device, which is again operating on a cellular network, that transfers the data over the internet to a remote monitoring site. What are some of the things that you might want to monitor are PV current and voltage measurements, how much of energy you are generating, what are the fault conditions, if anything, efficiency of the solar panel. This obviously gives you a way to measure if your investment is performing to the level that you are expecting, if it is generating the amount of energy it is supposed to be generating. You could measure up to a specific string of solar panels to check if they are, if some of them are malfunctioning. All kinds of analysis are possible from the data that you could capture out of this. So from a simple standalone system, now from continuous real-time data collections, you have started to use the asset much more efficiently with the application of an end-to-end technology like this. Oh, there it is. Okay, another interesting emerging application is medical device monitoring. And in the previous two applications we saw, it was the cellular technology being adopted for communication because of you need to transfer the data over a long distance. In this, Bluetooth is more of relevant technology. The reason is the medical devices are used by consumers in their home, maybe different types of people with a cell phone that has a embedded Bluetooth connectivity. Now, there are many companies that offer medical devices that are embedded with Bluetooth technology and that could connect to your cell phone, and the cell phones are in turn connected to the service provider or a back-end medical advisor to collect data about your health, how you're doing on a daily basis, and possibly provide you advice on a real-time basis. So this immediately enables a wealth of information to be both monitored as well as pushed from the service provider side for your for immediate patient attention and rectification problems. So this is another interesting application of M2M, where Bluetooth and the GPRS technology or the cellular technology are used in combination, And in this, the monitoring device is a typical cell phone. And there are also other applications where there is a medical gateway in your home. That gateway is independent of your cell phone, and that gateway could also be either with Bluetooth or in some cases Zigbee technology, and it takes care of transmitting your information every day, as well as receiving and showing you information from the doctor. Okay, another one is industrial monitoring. In the industry floor, recent trend has been to deploy wireless monitoring of process control systems. Some of you may know that the lot of industries are occupied with the Modbus protocol over RS-485 slave that may be running. Some of them may be running HART interface, and some of them may be running Ethernet interfaces in your factory floor. What essentially M2M can do in certain cases is to be able to deploy these wireless technologies connecting to the slave devices, and your master device is maybe your computer or your computer station that is monitoring all the devices. In this case, typically Zigbee is a favorite technology for using this. It operates on 2.5 gigahertz, and it has a very good mesh behavior, as well as self-healing behavior that provides reliability in certain situations. And another important reason is ease of installation. You just don't have to lay down cables from one end to the other end, where it is just impossible in certain cases. And in certain cases, there is a line isolation is also provided, and you can isolate the devices from one level to the other level, so the faults don't propagate from one device to the other devices. And remote data viewing is also possible. So this picture, in the master, instead of being a computer, it could be another cellular device that transmits all the information back to a browser or a backend system where you can process the devices. So this is an example of where you're combining initially a Zigbee in your factory floor, but then you can combine the Zigbee with the cellular to take it to the backhaul. So this is another interesting application of M2M, which is going to catch on more and more in the factory floor for some of the reasons that are mentioned here. Okay, I think the last one that I want to talk about is fairly complicated, but a very important application, which is hybrid power monitoring solution for telecom. The telecom towers that you are well aware of and you see around us they're all going through a lot of changes. One of the important dynamics that's happening is augmenting these towers with solar panels or windmills, such renewable energy sources, and having to monitor these telecom solutions, telecom towers, for the data and the operational efficiency. Imagine a situation where these telecom towers are in very remote areas of the country, and the operator or the maintenance person, also called NOC person, Network Operations Center people, are typically situated in the cities, and to get to these telecom towers itself, in some cases take a day or so. But these telecom towers have to be up and running all the time with the power either provided by the grid power, or if grid power fails, it has to be DG power, or in some cases solar is available, solar power is also available. But now you have so many types of instruments, and you have a challenge of monitoring the health of all these instruments, as well as controlling how you're using the power. And this is where the M2M fits in very nicely in getting the data to the central server. If you pry open this setup, there is a remote monitoring device, just like you have a remote monitoring device in other applications. And this in turn is connected to many instruments in the telecom shelter. And these telecom shelters may have AC energy meters, DC energy meters, control relays, or other power monitoring units. It could be anything, and potentially it could be connected through wires, or it could be connected through wireless, such as Zigbee technologies. And all the data is continuously monitoring throughout 24/7, and it could be monitored at 10 minutes every time, or on interrupt, any relay changes, immediately that information could be monitored. Now, once you get this information through the remote monitoring device, you transfer all the information over to the backend central server, and from that server, now you can analyze the data and respond. Instead of having a physical presence in every telecom tower, or even having one person per maybe a dozen telecom towers, now you can drastically reduce the amount of people required to monitor this huge infrastructure. And again, the thing that makes this possible is the monitoring solution, or a combination of wireless technologies, as well as the computing power that we can bring to bear on this problem in a very small, fairly small electronic device attached to these places. So this is probably at the high end of the monitoring solution for that is applicable in telecom. And before skipping to the next couple of slides, I have only touched or scratched the surface of M2M monitoring and control applications. Pretty much any electronic instrument or any electronic machine that has some information embedded in it and that can be talked to or interfaced to can be a member, or can be a potential candidate for an M2M application if you want to make use of that asset reliably and more in optimized way. There are applications where tracking is, people have been tracking temperature tracking for freezers that are moving around the country to make sure they are within the temperature range. There are applications where you could be monitoring theft of certain devices. That is very valuable assets. If they move out of a certain place, you could detect them based on the movement, or you can detect them based on misuse, or you can locate them with the GPS technology. So we have pretty much scratched the surface here in terms of the application examples, but hopefully I've given you an idea of what are the different types of problems that are being solved by M2M in today's world. And in your application, your own scenario either may be in a manufacturing floor, or may be in an operational scenario, or in a tracking situation, or in a home energy monitoring, or a smart grid monitoring, may all be slightly different from there. But the underlying technology of achieving this is fairly straightforward to understand if you get the components correct. And once you get the components correct, you have to match it to your own requirements to understand what is the right solution for you. So just to leave you with some of the points to consider when you are looking at deploying certain solutions like this. I talked about many wireless technologies, and there are many more wireless technologies out there like this. Some of them are standard, some of them are proprietary, but they all bring certain advantages and disadvantages to the particular problem being solved. So think about the wireless technology that you're choosing. Okay, does it solve the problem that you specifically have? You may solve it with the cellular technology, or with Bluetooth or Zigbee. It depends on what exactly you're trying to do. Application for processing the data is very important. It's just not enough that you collect megabytes of data, but there has to be an application to understand the data and exploit the data for realizing the business value. And that is a very important point. And it's not only enough to just get the data, but you have to process it as well as integrate it operationally within your business operations. Without that link, you will not realize the economic value of the data itself. And there may be some specific items for your situation that you'll have to consider. Latency of the data. Latency, for example, in factory flows, it may be very fast. Latency may be required. Make sure that specific wireless technologies can take that latency. There may be bandwidth issues. Maybe you are not just transferring data, but you're trying to transfer images, or you're trying to transfer video, and in those cases, think about the bandwidth. Environmental conditions, such as, are you going to be deploying this in open, under the sky, under all the weather conditions? Will the technology or the equipments work under those considerations? Heat, temperature, those kinds of considerations. Device diagnostics and management is a very important aspect of M2M as well. When you are talking about deploying maybe half a dozen devices around a network, it doesn't matter how the device technology. You can always send somebody over and do a device technology if they are close by. But when you scale it to hundreds of devices, you have to assume that one or two devices will fail in the field for whatever reason, and you have to have a method to diagnose the devices reliably and take action quickly, as well as to manage these devices. That is a very important aspect of M2M, and it is half technology and half operational excellence that you have to worry about. SIM provisioning and pricing. SIM provisioning is when you are using cellular devices, how we are going to be provisioning, how are you going to be purchasing the SIM, what is the SIM monthly charges you have to pay for, and those kinds of pricing are also something that you are very important that you have to keep in mind. Okay, so these are some of the top level points that I want you to keep in mind. So when you are encountering an M2M problem, you can think about how this is solved. Okay, good. In summary, hopefully I've given you an idea about where M2M is, what is driving it, and what are some of the examples, applications of M2M. I'll just like to summarize that. As we talked about, the M2M is really made possible in an increased manner by the low power computing, the various standard wireless technologies that have come up, and the embedded intelligence in all these devices that we see around us. This is really what is driving these M2M adoption and more. And the back-end side, I think we have enough software power on the servers and the databases that you can really manage these, the data set that is coming to you for processing the data. And we are still at the early stages of M2M technology. There are still a lot of new standards coming up. People are still trying to understand how these things can be adopted, and it's just our imagination is the limitation in terms of what type of problems can be solved, how they can be solved. And innovative solutions are for optimized asset utilizations are coming up everywhere. At the end of the day, this is about using your assets with the correct efficiency, with getting more out of your assets, and at the end of the day, realizing some business value out of it. So that has to be that can really be enabled by the M2M solutions. So start thinking about where M2M might fit in your business. You may not have thought about it before, but as some of the technologies are coming into viability, many problems that could not be solved before are getting solved with the M2M pieces. You may not even hear them as M2M technology, but they are getting solved in a manner that are very different from what they were even a few years ago. Okay. And thank you very much. I'll take the questions online. Okay. There is a request for sharing this file after the seminar, and you will definitely getting it from CII.
So you would have an audio recorded copy of this entire proceeding in my CII. So you would have a copy of it. That's the case in like most of the webinars that we do here. So you have a copy already. So I'll also kickstart some questions. There were a couple of things you said as considerations for before like selecting a vendor or like an M2M solution. One is the SIM network. Since we are tracking remote assets, a country like India is not well connected. So one thing is to monitor remote assets, and another thing is to account for outages of networks. So how does like one take a call on that?
Good question, Ashwin. True, there are certain pockets in the country where there is no coverage of cellular networks, and that may be true in other countries as well. Even if there is a coverage, what happens is there is an outage for a few hours or a day or so. The equipments that you can use do have a capability to, if the network is down, still continue to store the data until the network comes back up and then sends all the information. This is what is called a store and forward technology, and this technology essentially stores the information and sends it. And in other cases where a vehicle or an asset is moving across the country, and in some cases the the coverage is not there, again in a similar manner, it keeps collecting the information while it is moving, and even in the non-coverage area. And when it comes to the coverage area, it automatically sends all these things completely together. And obviously, the last but not least, if you don't have coverage at all, that is not the right technology for you, obviously, right? It's just the communication. It's just fundamentally not applicable at that situation. Okay.
Yeah.
And there's another question here: how to use the system to control fuel theft at DG? Okay. This monitoring system can tell you when the fuel theft has happened, how much has happened, and what is the severity of it at any point. But there is a human factor involved in this. It doesn't necessarily prevent, in the full sense of a thievery of the fuel. You can take action immediately to find out who was present at that time, or how you can immediately pinpoint the time of the theft, and that is what should feed back into your operational system to prevent the fuel theft. Another way of thinking about it is as you collect more and more data, and if there are theft going on in your system, you can see from historical data or empirical analysis that this particular DG is consistently consuming more fuel than it should, than the efficiency should predict. So, and that is an indication of some malfunction either in the DG or some malfunction, in this case it could be fuel theft. And these are the ways you could potentially analyze the fuel theft and take action. How you really prevent it, either you lock the DG or get into an investigation with the person who is filling the fuel. That's a different question that M2M will not solve fully, but that's an operational issue that you have to worry about.
But like with M2M, you can also say like whether the refilling of the DG is happening